Okay, so last time we looked at tuning the second resonant frequency of the vocal tract, and that's the second formant, or F2 for fancy people. And I showed you how perturbation theory predicts how I can tune the second formant, or the first formant, or basically any formant of my vocal tract, and how this really works. It really does predict how my vocal tract can be tuned. But perturbation theory, like I said, is kind of everything is fungible, one value for another. It doesn't really care about things like impedance matching. It doesn't care about nonlinear source filter interactions. But that's two out of the three concepts that we covered in this series. So what happens when we start to have other concerns other than just getting a particular resonant frequency with the vocal tract? Well, these values become non-fungible, or less fungible. So for instance, if we care about impedance matching, about making a nice loud sound, we can't afford to have a small mouth opening. If you want to really quickly experiment how this works for yourself, just cup your hands over your mouth like this, and notice how much louder you get. So what happens is you've made a kind of megaphone shape or a funnel shape. This funnel shape is quite constricted right where your hands meet your mouth. And that makes it easier to match impedance between your voice and then this air that's just inside of your hands. And then after that, it flares out. You have a kind of cone shape. And what that does is it helps match impedance of the air that's in my hands here to the actual room. Now that's an external thing, and obviously that's not what we're going to be doing while we sing. But let's say that I made the beginning of my vocal tract very narrow, and I made the end of my vocal tract very wide. Wouldn't that work exactly like when I cup my hands over my mouth? And the answer is yes. But the answer is also that when I do that, I change my resonant frequencies at the same time. That means as we go on, we're going to start to have more concerns than just what we could see on a spectrogram.